Swayam Prabha. Digital India. Educated India.
So, good morning and welcome to this next lecture on vibrations of plates and shells. So, last time we went till here where we looked at term 2. Okay. So, we will continue forward. Term 3 is pretty simple and already there. It is d alpha 3 squared is term 3. Okay. And the fourth term is twice alpha 3 dr dotted with dn. Okay. So, this now can be written as, I will straight away write it because we know both the terms from past. Okay. Del r by del alpha 1 dotted with del n by del alpha 1 d alpha 1 squared plus del r by del alpha 2 dotted with del n by del alpha 2 d alpha 2 squared plus del r by del alpha 1 dotted with del n by del alpha 2 d alpha 1 d alpha 2 plus del r by del alpha 2 del n by del alpha 1 d alpha 1 d alpha 2. Okay. Now, we should know that these two terms, this is a 0, this is 0 because this is in alpha 1 direction, this is in alpha 2 direction. So, we are left with A and B. Okay. So, what is the A term? The A term is twice alpha 3 into del r by del alpha 1 dotted with del n by del alpha 1 d alpha 1 square. Both of these we know before. Okay. This is A1, okay, and this is A1 by R1. So, we get twice alpha 3 A1 square by R1 d alpha 1 squared. Okay. Similarly, the B term. The B term is equal to twice alpha 3 A2 squared by R2 d alpha 2 squared. Okay. So, now we have, let us say, d alpha 1 squared. Then I have A1 squared, I have this term. So, I have A1 squared plus alpha 3 squared A1 squared by R1 squared. Then I have this term here plus twice alpha 3 A1 squared by R1 d alpha 1 squared. Okay, we are done with d alpha 1 squared. Then d alpha 2 squared, d alpha 2 squared d alpha 2 squared has this a2 square, then I have this plus alpha 3 squared a2 squared by r2 squared. Then I have this term over here plus twice alpha 3 a2 squared by r2 d alpha 2 squared plus one term that is left is d alpha 3 squared, d alpha 3 squared. Okay. So, you can see that this is a perfect square. Okay. The perfect square. So, how can we write it? We can write it as, so what is this? This is dr dot dr, we should not forget that, which is, for the moment let me put it as ds square. Okay, which is equal to a1 squared 1 plus alpha 3 by r1 whole squared d alpha 1 squared plus a2 squared 1 plus alpha 3 by r2 whole squared d alpha 2 squared plus d alpha 3 squared. Okay. So, what is this? We should not forget, this is the scalar distance between r, alpha 1, alpha 2, alpha 3 and the other point slightly away, alpha 1 plus d alpha 1, alpha 2 plus d alpha 2, alpha 3 plus d alpha 3. So, this is the distance which we are calling as dr. Okay. So, now this is our basic elemental length, or the square root of that is the basic elemental length. So, we will give this the name G11, this part we will call it G11, this part we will call this G22 and the one that is here will be called G33. Okay. So, what is it? I have ds square given as a summation from I 1 to 3 Gii alpha 1 alpha 2 alpha 3 d alpha I whole squared. Okay. So, this is important. Differential scalar length squared is given as this. This is the undeformed length, undeformed original length of a small element in the thickness of the shell. Okay. Now, the next step here is we would like to find the deformed length. Okay, the next step. The next step is to find the deformed length. we will call it ds dash whole squared. Okay. Now, how to connect? First thing is how to connect coordinate change because we are in curvilinear coordinates, some coordinates are angles. How to connect coordinate change to length change? Okay. So, if a certain point P at alpha 1, alpha 2, alpha 3, okay, is deflected is deflected by a distance u1, a length change, okay, length in length units u1, okay, then that u1 is equal to square root of g11 into xi1, where xi1 is the coordinate change. Okay. Or if the point P acquires these coordinates, these are the new coordinates, then the change in lengths are this square root g11 xi1 u2 is equal to square root g22 xi2 and u3 is equal to square root i3. Okay. So now we have a point P1, okay, we have a point P1 at alpha 1, alpha 2, alpha 3, okay, and there is another point, P2, which is at alpha 1 plus d alpha 1, alpha 2 plus d alpha 2, alpha 3 plus d alpha 3. Okay. So, this P1 undergoes a rigid body, or this element, the distance, the element between the two undergoes, okay, let's say it first. Then P1 goes to P1 moves to alpha 1 plus xi1, alpha 2 plus xi2, alpha 3 plus xi3, and P2 rigidly moves to alpha 1 plus xi1 plus d alpha 1, alpha 2 plus xi2 plus d alpha 2, alpha 3 plus xi3 plus d alpha 3. So, this element here has just rigidly moved. Okay, the element was here, the element is here now, it has rigidly moved. That is what this means. On top of this P2 goes a stretch. Okay. So the P2 now becomes alpha 1 plus xi 1 plus d alpha 1 plus d xi 1. Then alpha 2 plus xi 2 plus d alpha 2 plus d xi 2, and alpha 3 plus xi 3 plus d alpha 3 plus d xi 3. Okay. So those are the new coordinates. So let us say this is the point P1 now at this coordinate, this is now P2 at this coordinate. Originally they were. Originally P1 was here, originally P2 was here, just a d of alpha 1, 2, 3 away. Okay. So now P1 to P2 is deformed. P1 to P2 is deformed. Okay. So please remember, when we have alpha 1, alpha 2, alpha 3 and d alpha 1, d alpha 2, d alpha 3, the distance between the two is gi measured at alpha 1, alpha 2, alpha 3, and the differential comes here as a square. So now if the original, now we want to find the distance between what? This point and this point. You want to find the these two distance here. So what is the baseline here? Alpha 1 plus xi 1, alpha 2 plus xi 2, alpha 3 plus xi 3. So that will come over here, and all the d's will come over here, all the differentials will come over here. Okay. So now the deformed length I will now denote with a dash. Okay. So let us see how do we write the deformed length. So the deformed length, is written as ds dash squared is equal to now a summation I going from 1 to 3 gii alpha 1 plus xi 1, alpha 2 plus xi 2, alpha 3 plus xi 3, d alpha I plus d xi I whole squared. Okay. So this is the new length, new total length, deformed length. Okay. Now here we have to make some approximations. So let us see what approximations do we make. We will expand this in a Taylor series about alpha 1, alpha 2, alpha 3. Okay. So g I alpha 1 plus xi 1, alpha 2 plus xi 2, alpha 3 plus xi 3, okay, is equal to the base value at alpha 1, alpha 2, alpha 3 plus a sum over, let us say, j 1 to 3 del of GII alpha 1, alpha 2, alpha 3 by del alpha j xi j, okay, plus higher order terms, which we will drop. Okay. So, that is the approximation on this. Then we will do an approximation on that also. So, what is that? D alpha I plus d xi I whole squared is equal to d alpha I squared plus twice d alpha I d xi I plus d xi I squared. Okay. So, we have to accept that the d on the xi I is much smaller than the d on the alpha I. Okay. The coordinate change from an existing coordinate is much smaller, okay, than the original differential element. So, d alpha d xi I square we drop in comparison. Okay. So, these are the two approximations at this stage. Next. Okay. Now, what is d xi I? Okay. Xi I as a function of alpha 1, alpha 2, alpha 3 is a continuous displacement field. Okay. And therefore, d of xi I we write as a summation over j 1 to 3 del xi I by del alpha j d alpha j. Okay. And therefore, d alpha I plus d xi I whole squared is written as d alpha I squared plus twice d alpha I summation. J's and I's can get confusing, so I will be careful. I by del alpha j d alpha j. Okay. So, that's another stage. So, now if we combine the two, if we combine this expression and this expression, what do we get? We get d s dash whole squared is equal to summation I going from 1 to 3 GII alpha 1, alpha 2, alpha 3 plus sigma j is equal to 1 to 3 del of GII by del alpha j, okay, and xi j into d alpha I squared plus twice d alpha I summation j 1 to 3 del of xi I del of alpha j d alpha j. Okay. Now, because these things are getting lengthy, so I will use a shorter notation for this. I will write it as GII. It will be obvious that it is a function of alpha 1, 2 and 3. Okay. So if I shorten that, what do I get? I get, and do the multiplication, ds dash whole squared is equal to summation I 1 to 3 GII plus summation J del GII del alpha J xi J d alpha I squared plus, I am running out of space, so let me write it on the next page. My ds dash whole squared is equal to summation I 1 to 3 GII plus summation J is equal to 1 to 3 del GII del alpha J xi J d alpha I squared plus twice d alpha I GII summation J is equal to 1 to 3 del xi I by del alpha J d alpha J plus the one more term twice d alpha I summation J is equal to 1 to 3 del GII del alpha J xi J into summation J is equal to 1 to 3 del xi I by del alpha J d alpha J. Okay. Now this has two differentials. This has a differential here and a differential here, and this has a differential here, a differential here, and a differential here. Okay. So what we are going to do is we will drop this term over here. We are going to drop this term, okay, in comparison to the other two terms. Okay. So what we now have over here left is this term, okay, and this term which has a 2 in it. This 2 we will write it twice. Okay. So how do we write this? We write this as ds dash whole squared is equal to summation over I from 1 to 3 GII plus summation k 1 to 3 del GII del alpha k psi k d alpha I squared plus summation I is equal to 1 to 3 summation I is equal to 1 to 3 GII del xi I del alpha j d alpha j d alpha I plus the same term plus summation I is equal to 1 to 3, sorry, so this should be j summation j is equal to 1 to 3 g I del xi I del alpha j d alpha j d alpha I. Okay. Now this, let's look at the first term here. So we'll call this 1, we'll call this 2, we'll call this 3. Okay, so let's look at 1 over here. Okay. So 1 we write as a summation 1 to 3 g I plus summation to 3 del g I del alpha k xi k d alpha I square. I am going to write this now as a double sum. Okay, how do we make it a double sum? g I plus sigma over the k 1 to 3 del g I by del alpha k xi k and delta ij d alpha j. Okay, so delta ij is 0 when I is not equal to j. This is a Kronecker delta. Okay, or delta ij is equal to 1 when I is equal to j. Okay, you have seen this Kronecker delta before. So this term is written as a double sum using a Kronecker delta. Okay. Now the other two terms. What we do is the other two terms are actually, they are repeat. So what I say, sigma I, sigma j, g I, del of xi I by I del alpha j d alpha j d alpha I. This is the original term. Okay, it is equal to again the summation over I, summation over j, but this time g j j. I make j into I into j. Del xi j del alpha I d alpha I d alpha j. Okay. So if we do that, how will this term look like now? Okay, we made this into this term and we've changed one of them. Okay, we have changed one of them. So if we write this using a double sum outside, ds dash whole squared is equal to double sum I j g I plus summation over k del g I by del alpha k xi k delta ij plus g I del xi I by del alpha j plus GJJ del xi j by del alpha I d alpha I d alpha j. Okay, my time is run out, so I will stop here. Thank you.